Okay, so so on this video, I want to walk through two problems on page 59. Good challenge problems, good practice problems that kind of again hopefully get at the heart of this SSA ambiguous case. And when you introduce the sign function, you'll have to be careful because your calculator is programmed only to give you the principal answer, even though sometimes you might want its obtuse counterpart. Okay, so and if you haven't gone through that video, that one demonstration on GeoGebra, certainly do that because it's so much more dynamic than this. Obviously, I'm trying to give the sense that CB here, this say length here, that sort of can maybe like kind of arc through. Like go over here, maybe here's CB, or maybe here's CB, or maybe here's CB. And so, it's supposed to be, swinging back and forth here to kind of, again, replicate that motion that we saw in that GeoGebra activity. But the things that are fixed are this angle here, so that we know that that's 30 degrees. We know AC is 48, so we know this has to be 48. And then it says CB can be any length, and obviously angle C can be between 0 and 180. Find all values of CB that would guarantee the following situations. Okay, so one of the situations is says, let's make it a right triangle. I believe that's the first one. I think let's just double check. ABC is a right triangle. So the most obvious one, or maybe the one that comes to mind first, is just make CB straight down here. Make that your right angle. So now you're sitting in this particular triangle here, where AC is the hypotenuse. There's your right angle. And so if this is like a 30, 60, 90 triangle, whose hypotenuse is 48, that's the 2x position, which would mean that one of our possibilities of CB, there we go. One of our possibilities of CB would be 24. Because then that would give me my 30, 60, 90 triangle. Now, one that might not be as obvious or may not come to mind as quickly is actually if you let your right angle not be angle B, but let it be angle C. Like, why can't this angle up here, and in hindsight, it almost looks like that almost is a right angle. What if that was our right angle? And what if CB went this way? So if that's the case, if that was a right angle there, then my 60 degree angle would be here. So now 48 is opposite 60 degrees. So now that's in the x root 3 position. So 48 is in x root 3, which means x is equal to 16 root 3, which would be side opposite 30. So 16 root 3 could work to give us a right triangle. We have to be careful of, though, is that 16 root 3 also would give us a non-right triangle over here. So again, because if that would have swung over here, that value of 16 root 3 could also have made a triangle that's not a right triangle. So like I would say, well, 24 guarantees it. And I'd say that CB equaling 16 root 3 could give it to you if, like I said, if you take it, it's this angle out here, not the one that would have been there. Okay, how can we make a triangle not formed? Well, we just make sure that CB isn't going to intersect or touch, there's the eraser, sorry, the line that's on the ground here. So as is right now, CB won't quite make it. And like a good way to solve this and answer this is to think about, okay, well, what's like, when would it just skim the surface, right? And it's going to just skim the surface when you pick the height of it. So if you knew what the height was here, and again, this was 30, we said this is 48. So if you knew what this height was of the triangle that, let's say, is here, just make sure your CB is less than that height. So I could figure out what that height is. I know that's 30 degrees, that's 48, and that's the height. So I can go back and, oops, wow, I have no idea what just happened there. That's exciting. Well, somehow I went side by side. I've never done that before. Look at that. How cool. Ask me to do it again. I have no idea. Okay, so the height, right? So then that's what I wanted to do. And probably pick this color. So I could say the sine of 30 equals height over 48, and then just solve for that. Oh, it's a 36-90 triangle. So that was really silly of me. As long as 48 times 1/2. See, I'm still mesmerized by that side by side. So 24. So as long as CB is less than 24, no triangle would be formed because it would not be long enough to hit down there. Okay, two different triangles, two distinct triangles. So that we need to make sure I'm bigger than 24 so that when this swings through, it'll intersect in two different spots. So I definitely need to be bigger than 24. And then as this gets bigger, as we saw in the GeoGebra, it gets closer and closer and closer to that given length of 48. And so the closer it gets, the smaller and skinnier that triangle is. In other words, I can't go past here. I can't go past 48. So I have to be in between 24 and 48. And again, if that's a little bit confusing, go back and look at that GeoGebra exercise and kind of play around with that a bit. One triangle formed. Well, we found one triangle when it was exactly 24 because it was a right triangle. It was just tangent there. And then, so CB could be 24. But then as long as I'm greater than or equal to 48, I will just get that one triangle that's on the outside, because as soon as I pick 48 works because I'd get this big isosceles triangle, but then I would never get anything that's over here because when it swings over, it's going to be a triangle that doesn't have AB on that value for angle A being 30 degrees. Okay, so that's just a good application problem. I think there's one like that on the homework, so hopefully that made sense. Okay, for problem number 2, I think go ahead and a good exercise would be to pause the video and actually solve this, and then look at the solution here. So take a second if you really want to pause it and try to see if you can figure out what's wrong. Okay, so hopefully you've paused the video. We could see what's wrong, and the thing I'm noticing is they solved for cosine of angle C first, and they didn't do anything wrong. They found cosine of C perfectly. It's 10 squared plus 8 squared minus 5 squared over 2 times 10 times 8, and they got that angle to be 29.69. There's nothing wrong with that. That is the angle. Okay, but then look what they solve for next. They solve for angle A second. And here's my caution. And the thing about angle A is opposite the largest side, right? 10. So if any of these angles were going to be obtuse, it would be A. So that's a little suspicious, right? A is suspiciously obtuse. If you're going to go find the next angle and one of them might be obtuse, then what you should have done was solve for angle B first, then angle A. Because if you solve for angle A, your calculator gave you 82.14. And you might reason okay, that might be right? But the thing is, there's another angle out there that has the same sine ratio, which is actually 97.86. And so we don't know, it's only one of them because you're not in an ambiguous case, but we don't know which angle A fits this triangle. It certainly looks obtuse. I mean, it looks acute, but if all the angles it could be obtuse, that's the one that could. So I have to be really careful. So what I should have done actually solve for angle B first. And when you solve for angle B first, you know that it was guaranteed to be an acute angle because opposite B is the second smallest side. So if you would have done that first, you got that. This is right, 52.42. So you have your 52.42 and you have your 29.69. And now you know 2 of the 3 angles. So you could have just subtracted those 2 from 180 if you wanted to. 52.42. And when you do that, you subtract them, you get 97.89, which I think, unless I did my math wrong, Oh yeah, so off by like a hundredth or something like that, or 200ths or 300ths. But it proves or shows that, oh yeah, this angle up here was obtuse. So rather than getting that one first, I should have solved for angle B. So that and that's what you have to be careful of when you use law of sines. So you use law of cosines first, great. You could solve any of the angles. When you go back and solve for the second angle, pick the smaller one. Or if you had any choice in solving this, maybe even a better solution would be if I'm right at the beginning saying, oh, okay, how should I solve this? I need to pick one of the angles. I'm going to use law of cosines. Go for the one that's biggest. If I would have solved for angle A first, using law of cosines, I could have said, okay, so cosine of angle A is equal to 8 squared plus 5 squared minus 10 squared all over 2 times 8 times 5. And if I would have solved for that one first, remember, law of cosines, there's no ambiguity. So if it was going to be obtuse, it would exactly give me obtuse angle. Minus 10 squared, I'm getting really excited here. Divided by 2 times, parentheses, 2 times 8 times 5. And if you do inverse cosine of that, you get 97.90. So again, depending on how you solve and where you round, you might be off by 100th or 1,000th or something like that. But I'm getting 97.903 degrees. And clearly that's obtuse. So that's the word of caution. If you're going to use law of sines, pick an angle that you are guaranteed to be acute, especially if that's like the second step of solving a question where you first had to use law of cosines. Okay, so good problems. Again, just some things to work through that we have done in class. If you have any questions or making mistakes, let me know in the comments. Otherwise, continue working through the modules.